Dogs are getting better. This last generation doesn't show much improvement because when this slide was put together, those dogs are still the ones in production. We don't know much about them at that point. What about hip dysplasia and abnormality of development? We talked about it earlier. OFA is one method of assessment used in the U.S. FCI is in Europe. The BBA scheme is here in Australia and in the UK. And DSP is the German scheme. It's a score based on hips that are in the extended view. A normal radiograph is shown for a 31-month-old dog on your left. That was a Rottweiler. The one on the right, I think, is of that same dog at 43 months of age, where it's begun to show some significant signs of developing hip dysplasia, mild hip dysplasia at 43 months of age. And these were images provided by Dr. Smith, the developer of the pin-hip methodology, now owned by Antec, the diagnostic entity. If you're going to use the extended view score, we know it's the most common method for evaluating hip quality. It does assess osteoarthritic changes in hip joint conformation, but we need to make these decisions when the dogs are young. This view is not very good at assessing joint laxity, which is a much better predictor of the likelihood a dog will develop osteoarthritis as it advances in age. But the accuracy of an extended view score does increase with age. At 12 months, it's not nearly as accurate as if you could do it at 36 months of age. But none of us who are breeding dogs want to keep a dog to 36 months of age to assess hip quality before we allow the dog to mate. And there are lots of other reasons from a reproduction health point of view why you want to breed them earlier, younger ages rather than later ages. So the recommendations. Normal dogs, if you're not using EBVs, you should keep normal dogs from litters where 80% are normal and where parents and grandparents are normal. That's the standard OFA recommendation if you look at their website. That's a hard criterion to meet. You need to radiograph all or most of your dogs. Many of our guide and service dog organizations have to make our decisions at ages younger than 24 months. So many of us are making them at 15 months, 14 months of age. It's better than at an even younger age, but it's not nearly as good as if they're older. And if you've kept a dog for breeding, a lot of organizations like to repeat the radiographs at 3 years of age just to know how the dog has changed. But often, if it's a male, you've already got several offspring by it. A female, you've got 1 or 2 litters by then. What do you do with those if she's now dysplastic? If you've got the data, this is a summary from Guiding Eyes for what happened with their extended view score. It's amazing to me. These data started in 1991. They go all the way out through dogs born in 2016. These are summarized by the year of birth, by year born, and they are using estimated breeding values to help make their breeder selection decisions. So if you look at the scale up here at the top, the dogs with severe hip dysplasia by this method were in the light blue color. And if you look at here in 1993 are the few dogs that I see on here with severe hip dysplasia, a few more in 96 and 98 and so forth. Moderate are the orange ones. mild are the gray ones. So these are the bars, the portions of the bars down here at the low end. The dogs with fair hips are the dark blue. The ones with good hips are the green, and the darkest blue are the ones with excellent hips. And I think what you can see over time is that there's been a steady disappearance of animals in these lower bars out here to 2012 and 13. I've heard Jane discuss this slide, and in 2014 and 15, these were offspring of some dogs brought in from outside germplasm that resulted in a few offspring being produced in those years that showed evidence of hip dysplasia. But in general, the trend was to produce a lot more dogs that were of excellent and good hip quality, while steadily eliminating the production of dogs that had signs of hip dysplasia. It's better summarized on this graph of the estimated breeding values for hip quality by this metric, where now the x-axis is tracking generations of selection rather than year of birth. An upward trend is desired, and a disappearance of animals in these lower, with these lower hip EBV values is desired. That means the population is becoming more similar and it's improving. You remember back from the slide on how much selection pressure was being put on hip quality. I think it was 8% of total selection pressure was being applied to improve hip quality, meaning they weren't putting a lot of attention on hip quality at this point. But it's still showing some evidence of slight increase in these latter generation classes. If you can evaluate hip quality using the PIN-HIP method, and I know it's not available in all parts of the world, and it's not available in all states of the U.S., but if you can use it, you will use it because you know it measures joint laxity instead of other indirect measures of hip quality and instability in the joint. It is accurate from 6 months of age onward. It's repeatable. If you take a measurement on a dog that's 6 months of age and you repeat it at 12 months of age, you're very likely to get a similar value on most dogs. It's not perfect on every dog. I know anyone who's done repeated matings on the dogs has some examples where at 6 months of age they got something, and at 12 months of age it was substantially different. Those are anomalies. In general, it is repeatable from 6 months of age onward. All the analyses I've done about estimating heritability for it, it's about 60% heritable. That means that what you see in an individual dog's measurement is a pretty good predictor of its genetic worth. It's not as good as if you could use estimated breeding values, but it's pretty good. It accurately predicts the risk of developing osteoarthritis as it ages. Any of you interested in details of that statement are encouraged to go read the papers written by the group that studied Labrador retrievers at Purina in the U.S. Purina took pairs of full sib brothers. They put them on feeding trials and followed them for a lifetime. And until the dogs died of old age, whenever that was, they collected measures of overall health and measures of hip quality every year. You can read in those papers how things changed over time. The dogs that were kept lean lived longer and developed, if they were developing osteoarthritis, they did it at later ages. But the pin-hip method from a young age onward was always more accurate in predicting which dogs were going to develop osteoarthritis at later ages than the extended view scores. It's a great set of papers. If you're really interested, I can find you the references. So in general, our recommendation, the pin-hip score is best if you can get it. You need to do it only once. You can test just your breeder candidates if you want to, but it would be better if you can test all your dogs. I know it's more expensive, but that would be your best information. And if you can put it in a database that calculates breeding values for you, EBVs, that makes it even better. What you want to avoid is breeding dogs which have high values for the distraction index. This is one of those phenotypes where lower numbers are better numbers. I've seen German Shepherds with values of 0.11, 0.15. Generally, dogs that have values below 0.3 have a very low risk of ever developing osteoarthritis as they age. They'll develop more likely other issues as they get older than hip dysplasia. So if you can do pin-hip, that's the best. And if you can do it, this is an example of German Shepherds at Guiding Eyes. This is the small group that they have evaluated using pin-hip scores and using EBVs. It basically illustrates mostly the same things. Oh, I'm sorry, it says no EBVs. So they're basing their selection decisions only on what they see on the individual dogs. They're not taking it, they don't have the advantage of additional information on the relatives. At the Seeing Eye, we had EBVs, we had pin-hips on, I think, about 10,000 dogs by the time I retired. It was helping improve hip quality steadily when we began using it as our primary criterion for assessing hip quality. Elbow dysplasia is another one. Many of you are working with breeds that have where elbow dysplasia is a problem in the breed. For some reason, it seems to be more common in males. It does respond to genetic selection if you can get good data on lots of relatives. The radiographs may be normal and when they're young, but then they develop elbow dysplasia as they age. The same standard recommendation from that of the OFA on hip quality. For elbow dysplasia, keep normal dogs for breeding from litters where 80% are normal. Tough to do. Best if you can do it at age 3, but you really need estimated breeding values. This is a more difficult trait in my mind for people to do anything about because the elbow is a complex joint. There may be 3 different diseases operating in the joint. You need to really get the radiographic views recommended by whoever is scoring your radiographs and get your radiographs scored by someone who will use the scheme of the International Elbow Working Group. If you do all of that, you can make improvement in elbow quality. At Guiding Eyes, it did respond fairly well to selection, so that in these later years, you see down here on the x-axis tracking by year of birth, they were not seeing very many dogs showing any evidence at a younger age of elbow dysplasia. As I said, it's best if you can use estimated breeding values. It was responding to selection in these later generations after they began using estimated breeding values here at about the 7th generation class. The trend is upward, meaning the elbows are of better quality. And in these various classes, there are fewer dogs down here in the outlier range, and the grouping of dogs is getting tighter, meaning more and more of them are normal. So EBVs will help you if you can get the data. Success, we talked about this one as another metric to use. It has been successfully employed as a selection criterion at Guiding Eyes based on the dog's status, where success was considered to be any dog that worked as a guide dog or was kept for breeding. They had about 53% of their dogs in that category when this slide was put together, with 47% in the failed category. Fixed effects included in the model were sex and contemporary group, with males being slightly more successful than females. The heritability by one measure was only 0.16. My recollection of our earlier slide, I think this was 0.44 by another method for assessing or estimating heritability. It does have some issues with it, hence this statement, it's not an ideal measure, but if you don't have anything else to work with, at least it's a way of assessing the population and beginning to pick out which young dogs would come from families that are most likely to be successful. From Guiding Eyes, this was one way of summarizing the data. I find that one a little bit hard to explain, but this one's a lot easier to explain, looking at the change in estimated breeding values after they started using EBVs. Prior to that, they didn't have good data on available for the analysis, but from this time on, as the generations accumulated, the dogs were steadily getting better, with not too many showing up in the outlier classes at the lower end of the scale. I don't know about you all, but I'm beginning to reach my limit on all this stuff. Osteochondritis dissecans, another cartilage disease seen in elbows, hocks, knees, and shoulders. Another condition on which selection pressure may need to be applied. Not too big a problem in most of the guide and service dog world, but it can be a problem with some of the larger breeds of dogs. If you're going to, if you're working with a breed where it's a problem, then some attention needs to be put on it. Tricuspid valve dysplasia, one of the heart conditions that has cropped up in some